Problem number 3 states, a truck with a mass m equals 15,000 kilograms traveling south in the negative y direction at 20 meters per second collides with a car with a mass m equals 2,000 kilograms traveling west in the positive x direction at 30 meters per second. The car and truck stick together and move as a single unit after the collision. They want us to find out what the velocity and the direction of the car and truck after the collision is. So, first thing I've done is written out the variables given to us. So we have the mass of the truck, initial velocity of the truck, the mass of the car, initial velocity of the car, and they want us to find out the final velocity of both the car and truck stuck together. So immediately we know that this is an inelastic collision because the car and truck stick together afterwards. So we know that momentum is conserved. So the final momentum will be equal to the initial momentum. We also know to calculate momentum, you need to multiply the mass times the velocity. And since we're finding velocity, we can just rearrange that to divide that momentum over the mass. So I've drawn out a figure here. On a coordinate system, we have our truck traveling south at 20 meters per second and our car traveling west at 30 meters per second. And they are going to collide, and we want to find out the velocity, the magnitude of the velocity after they collide, as well as which direction. So I've labeled this angle here theta for our calculations. So the components, since we need to break this up into components, those are going to be the velocity in the x direction is going to be velocity times the cosine of theta, because we are looking for that adjacent, or we know the adjacent over the hypotenuse, and then opposite for the y component, we need it times it by the sine of theta. So to calculate our momentum, we are going to start in the x coordinate, or on the x axis. So yeah, the momentum in the x direction, or the west direction, is going to be equal to the mass of the car times the initial velocity of the car, because that's the only thing going in the x direction. We can leave out the truck in this one because it's traveling straight down on the y coordinate. So just those two going to give us 60,000 kilograms times meters per second for the momentum in the x direction, and for the y direction, or south, we're going to just use the mass and velocity of the truck. So we get 300,000 kilograms times meters per second for the momentum in the y direction. So now we can use those momentums to plug into our v equals p over m. So we know v in the west direction, or on the x coordinate system, is equal to the final velocity times cosine of theta. So we can plug that in here, and that's going to equal 60,000 over our total for our masses. So 17,000 for both the car and the truck. So we get 3.53 meters per second is going to be our momentum in the, our velocity in the direction of west. Same thing for our y coordinate, so south, just plug in that f of y equals sine of theta, and get 300,000 kilograms times meters per second over 17, which leaves us with 17.65 meters per second in the south direction. So now we can take both of those to eliminate the final velocity and find our theta. We just need to do the sine over cosine, tangent of theta, plug in those numbers that we just got, and we get 78.7 degrees And then we can calculate our final velocity by just using that x coordinate, dividing it by the cosine of 78 degrees, and we get our final velocity of 18 meters per second. So car and the truck are going to travel at 18 meters per second, 78.7 degrees south of west.